In this video, we will be solving two log equations, one in front of you and one yet to come, that we will need to combine two or more logs together in order to be successful in solving these. Before I even start, I want to point something out. I see 7 is inside of a log. I see x plus 2 is inside of a log. But this minus 1, this is a constant. It's not inside the log. So this is telling me, this is my signal, my big fat signal that we will need to rewrite in exponential form. And I'm going to write eventually. We can't quite do it yet. We can only rewrite in exponential form when you have a log equaling some number. And we clearly do not have that form up here. So let's see. Maybe we should get all the logs on one side. I think that's going to be a good idea. And so what I'm going to do is I'm going to have to subtract this log to the left side. And when I do that, the equation will end up looking something like this. I put the log, when I subtract it, it would cancel over here and leave you with a 0. So I subtract it over here and I just kind of put it in between this first log and the minus 1, just for simplicity's sake. The next thing I need to do in order to get this log, one log equals some number form, I think I want to add this 1 to the other side. There we go. So I added 1 to the left side, and that canceled here, and I added 1 to 0, and I got 1. Now we're getting really close. I have this log equals some number. What I need to do now is combine these two logs together. And I see a subtraction. So I know that when I condense two logs into one, a positive log argument will go on the top and a negative log argument will go on the bottom. So the new equation will look something like this. There we go. The top argument is from a positive log. The bottom argument is from a negative log. All right. Now we can rewrite in exponential form. But in order to be successful with that, you have to know what base you're working with. I don't see a base. Well, if you don't see a base for an log log, that means your base is 10. So now I know all the information, and I'm going to rewrite my exponential equation over here. And I know that the base of the log will be the same thing as the base for my exponential equation. So I know the base here will be 10. I know the log equals the exponent, so I know this is the exponent, and that the exponent goes with the base. So this is 1, the exponent is 1, and this exponent to the base to the exponent will equal the argument, so 7 over x plus 2. Now all we need to do is multiply both sides by LCD, and the LCD in this case is x plus 2. So let's go ahead and make that happen. X plus 2, that'll cancel, and I'm going to multiply this by x plus 2. So this leaves me with a new equation of 10 times x plus 2 equals 7. How is this going to work? Let's see what's going on. We need to distribute the 10 here and here. That's 10x plus 20 equals 7. Then we need to solve for x, which involves subtracting 20 from both sides, and then dividing both sides by 10. And that's how you solve for x. Now, since this is a log equation, we must check our answer. So that involves taking our answer, x equals negative 13 over 10, and substituting it in for all the x's we see. I just see one x right here. Cool. So negative 13 over 10 plus 2. Oh, I don't know what negative 13 over 10 is. Let's approximate it as a decimal. It's negative 1.3. Now I understand this a little better. Let's see what happens here. Negative 1.3 plus 2 is a positive 0.7. So our argument ends up being positive. That's fine. We're looking for positive arguments. That means this answer is a good answer. On to example 2. This one is set up a lot nicer than the last one. So here we have log base 3 of x minus 5 plus log base 3 of x plus 3 equals 2. Now again, this constant is floating around. It has no log to call home. So that's how I know eventually I'm going to have to rewrite this in exponential form. But before I can do that, I need to combine these two logs right here into one log. And since these logs are both positive, their arguments will both be in the, quote, top of the fraction, meaning they won't be in the bottom of a fraction, and they're going to get multiplied together by the power rule here. Now that we have one log equaling some number, I can rewrite this in exponential form. So this would be 3, that's the base. The log equals the exponent goes on the base, so 3 squared equals x minus 5 times x plus 3. Now this, I see a binomial times another binomial. This is probably going to be quadratic. Let's FOIL it out, see what happens. Yep. It sure is quadratic. All right, let's see what happens here. So I have something quadratic on the right. I squared the left. That means we're going to need a 0 on one side of this equation. So I'm going to go ahead and subtract this 9 over here so we can just continue with this and get our factoring over with. So here are the next couple steps. I subtracted 9 from the left and got 0. I was able to combine the minus 9, subtracting 9 from the negative 15 to get negative 24. And then I factored this trinomial into x minus 6 times x plus 4. And the answers from here are pretty simple. You can just basically look at it, say x equals 6 and x equals negative 4. So now we have to check our answers. I'm going to take 6 and put it in for all the x's up here. And I need to make sure the entire argument is positive. So 6 substituted in here, 6 minus 5 is 1, that's positive. The argument is positive if 6 is substituted in for x. If I take 6 and substitute it in here, 6 plus 3 is 9, that's positive. Both arguments are positive. When we substitute 6 in, that is a good answer. Now let's try negative 4. If I substitute negative 4 in for this 1x, negative 4 minus 5 is negative 9. That's a negative argument. All you need is one argument to be negative, and this answer is no good. So the only answer here is 6, and I very much hope that this video helps you out.